Hi everybody, and welcome to exercise 3 on page 64 of the workbook. And in this video we're just going to be working through a couple of parts of this problem so that you can kind of get an idea of how to do the other two on your own. Okay, so let's read this together. So they start us off with a constant c and a couple of differential equations that we're seeing over here. And the idea is we want to take these functions that they're giving us and to check those one by one and to see which differential equation or equations they might be solutions to. All right, so let's start with part A. Okay, x equals c e to the 2t. We want to check and see first if that's a solution to the first differential equation, and then second if it's a solution to the second one. All right, so we'll start with differential equation number 1, and we would like to check x equals c e to the 2t. Okay, well, the idea again to check to see if something is a solution is just to ask yourself, does it make the differential equation a true statement? Okay, so we're going to substitute x into the differential equation and see if we get the same thing on both sides. All right, so as we did before, we'll start by just noting what the left and the right-hand side of our differential equation are. Okay, the left-hand side is dx dt and the right-hand side is 2x. And then we're going to substitute x in, okay, for in both of those cases. And in our case, x is equal to c e to the 2t. So we will literally substitute it in for the x's in both the left and the right-hand side. Whoops, I wrote 2 twice. Sorry about that. Okay, so we substituted our x in, and now we're going to do the calculations and see whether or not we get the same thing on the left and the right. So let's start with the left-hand side. So this is telling us take the derivative of c e to the 2t. Okay, if we do that, c is constant, and you take the derivative of e to the 2t, you're just going to get e to the 2t, and by the chain rule, times 2. Okay, if we simplify that a bit and maybe put the 2 and write it together with the c, we're going to get 2c e to the 2t. There's the result of the left-hand side. Okay, now what happens down here on the right-hand side? Well, in this case, there's no derivative to take. What we see is just 2 times c e to the 2t, which we could rewrite as just 2c e to the 2t, and that's really all we have to do on the right-hand side. Okay, and then the question is, did we get the same thing? You bet we did. Those are equal. And we have just confirmed that x equals c e to the 2t is a solution to the first differential equation. Okay. Well, what about the second differential equation? Okay, the one that's sitting over here. Might c e to the 2t be a solution to that as well? Well, let's check it. Okay, so we're still talking about the function c e to the 2t, but this time the differential equation is different. So the left-hand side is going to be x double prime, and the right-hand side is going to be negative x. Let's fill those in. Okay, we want to substitute in our candidate for a solution, c e to the 2t, into the left and the right-hand side and see if we get the same thing. So let's do that. So c e to the 2t in for x there, and in for x down here. And we'll do those calculations separately and just see what happens here. Okay, so first of all, what does that double prime mean? Well, that's just asking us to take 2 derivatives of c e to the 2t. We already took one derivative up in part A and discovered that you take the derivative of c e to the 2t, you get 2c e to the 2t. Okay, now we need to take the derivative again. So let's see, 2c is a constant, and the derivative of e to the 2t is e to the 2t times 2. Put all of our constants together, and that simplifies to 4c e to the 2t. And there's the result of our left-hand side. Okay, and what about the right-hand side down here? Well, there, all we really have to do is to negate the value of x. So there's not much to do at all there. We could maybe rewrite it as negative c e to the 2t. And the question again is, did we get the same thing? Okay, this time we don't get the same thing on the left and the right-hand side. Those two things are not equal. So we have just confirmed that ce to the 2t is not a solution to the second differential equation. Okay. So we have just completed part A, discovered that it's a solution to differential equation 1, but not to differential equation 2. Okay, so let's move on to part B here again. All right, I'm going to clear away a little of the clutter here. And we are going to check 2 cosine of t and see if it might be a solution to either of these differential equations. All right, so we'll start with the first one. Now we are trying to check the solution, x equals 2 cosine of t. And let's see, just to remind ourselves what the left and the right-hand side of differential equation 1 are. Okay, again, we're going up and noticing that we're looking at that differential equation. So the left-hand side is dx dt, and the right-hand side is 2x. Okay, so if we substitute the value of x in that we're checking, 2 cosine of t, okay, put x in for the, or put 2 cosine of t in for the x up there and also down here. Okay, starting with the left-hand side, that's asking us to take the derivative of 2 cosine of t, which is 2 times minus sine of t, okay, which we could also write as just minus 2 sine of t. There's the result of the left-hand side. And the right-hand side, we're just multiplying 2 times 2 cosine of t, which is going to give us 4 cosine of t. All right. Do we get the same thing? No, we do not. Those are not equal. Negative 2 sine of t is not the same as 4 cosine of t. And so we have shown then that x equals 2 cosine of t is not a solution to the first differential equation. Okay, what about the second one? Okay, now we're going to check the same function, x equals 2 cosine of t. Okay, if we sneak a peek back at the differential equation, sorry for the scrolling, but just wanted to remind you that that formula there is the second differential equation. Its left and right-hand sides are x double prime and negative x. Let's write those down. Okay, and this time we're going to substitute in 2 cosine of t for our x's. Okay, so all right, let's do these calculations and see what happens here. So for the left-hand side up here, we're being asked to take the second derivative of 2 cosine of t. The first derivative we already know is negative 2 sine of t. And what do we get if we take the derivative again? Well, we're going to get negative 2 cosine of t. All right, and down below on the right-hand side, again, not a whole lot to do there. We're just taking the negative of 2 cosine of t, which is going to give us negative 2 cosine of t. Okay, so what do you think? This time, we did get the same thing on the left and the right-hand side, and so we have confirmed that x equals 2 cosine of t is a solution to the second differential equation. All right. So I'm hoping that that might help you to do part C and D on your own.